When Elon Musk announced that his factories would be capable of producing one car every 40 seconds, the automotive industry responded with skepticism. The largest manufacturers with century-long histories didn't take it seriously, but it's precisely this arrogance that may cost them the market, because Tesla is already changing not the car itself, but the very essence of how cars are made. For over 100 years, the global automotive industry operated according to the same model. Thousands of individual components are produced at different facilities, then transported to an assembly line where hundreds of robots weld them together, and thousands of workers sequentially assemble unit after unit. Toyota, Volkswagen, Ford, General Motors. All of them followed this logic for decades. It had been refined to perfection. It seemed impossible to improve upon. Musk asked a different question, not how do we assemble a car faster, but why assemble something from 100 parts at all when it can be cast in one piece? This question, simple to the point of being disarming, launched one of the most radical manufacturing revolutions in the history of the automotive industry. The answer was the gigapress, a colossal casting machine capable of transforming molten aluminum into a single unified component under enormous pressure. Where dozens of individual metal stampings and hundreds of welds were once required, a single monolithic structure now takes their place. Several generations of these machines are already operating in Tesla's factories, and future versions are expected to deliver even greater clamping force. At first glance, it appears to be a straightforward engineering improvement. In reality, it's a systemic shift. At Tesla's factory in Texas, the introduction of the gigapress made it possible to eliminate roughly half of the welding robots. Fewer parts means fewer joints. Fewer joints means fewer defects, and fewer defects means lower production costs. Buyers don't see this, but it's precisely what affects the final price of every car. However, the gigapress is only the first step. Tesla is going further with a concept the company calls the unboxed process. The idea is this. Rather than moving a car through hundreds of meters of sequential conveyor line where each component is installed in strict order, Tesla divides the vehicle into 6 independent modules. The front section of the body is assembled in one area, the rear in another, the battery pack on a separate line, and the interior in parallel at its own station. All modules are produced simultaneously and joined together only at the final stage. According to Tesla's calculations, this approach can cut manufacturing costs in half, reduce factory floor space by nearly 40%, and increase production throughput by a third. The first car to come off the line under this system is expected to be the Cybercab. Musk has cited a target production cost of around $30,000 per unit, with the prospect of further reductions as the process scales. The full launch of the unboxed process is planned for around 2027. While the new system is being refined, the heart of production remains what is known as the body shop. This is where automation reaches its limits. Unlike the final assembly area, where people and robots work side by side, the body shop is an almost entirely robotized environment. Hundreds of robotic arms operate around the clock, performing thousands of welding operations on each body shell with precision down to fractions of a millimeter. This is what Musk was referring to when he described the Tesla factory as the machine that builds the machine. The robots here employ several joining technologies simultaneously. Resistance spot welding secures sheet metal at thousands of critical points. Laser welding is used where maximum precision is required. It produces a cleaner and stronger seam. High-strength structural adhesives are also applied, increasing the torsional rigidity of the body and reducing vibration. It is precisely this combination of technologies that is one of the reasons Tesla vehicles consistently perform well in crash tests. The key advantage of robots here is not speed, but repeatability. A skilled specialist may work superbly, but after many hours of continuous labor, minute deviations are inevitable. A robot reproduces the same movement thousands of times without any loss of precision. This ensures that every body shell leaving the shop meets the same quality standard. After the body shop, the car moves to the paint shop, one of the most technologically complex areas of the entire factory. Here, even a microscopic particle of dust can ruin the finish and send a body shell back for rework. For this reason, temperature, humidity, and air cleanliness are controlled with pharmaceutical precision at every stage. The process begins with a thorough cleaning of the body shell to remove any contaminants left over from production. The shell is then submerged in an electrophoretic priming bath, known as e-coating. This method applies a uniform anti-corrosion coating to all metal surfaces, including hard-to-reach areas that a spray gun simply cannot access. This is one of the key stages that provides long-term protection against moisture, road salt, and corrosion. A layer of primer follows, creating a reliable bond between the metal and the top coat. Only after this do robotic systems apply the color coat and protective lacquer. Each layer is cured in an oven at a precisely specified temperature. The result is a smooth, glossy finish designed to last for years of use. An interesting detail: the paint shop is one of the few areas where several Tesla models pass through a shared line before diverging onto separate assembly tracks. The Cybercab will be an exception. Tesla plans to integrate color and protective coating directly into the casting process, eliminating traditional painting altogether. But it's worth pausing here on an episode that is often glossed over, and unjustly so. In 2018, in the midst of the Model 3 production ramp-up, Musk set a target of producing 5,000 cars per week. To achieve this, he decided to automate the factory to a degree no one in the industry had dared attempt. Robots were assigned tasks traditionally performed by people: laying wiring harnesses, fitting interior components, transporting parts between stations. On paper, it looked flawless. In practice, it turned into a disaster. The robots handled rigid, geometrically predictable components brilliantly, but with flexible materials, wiring, insulation, they couldn't cope. The slightest displacement of a component by a few millimeters would bring the entire chain to a halt. The conveyor would stop. Unfinished cars sat idle on the floor. Spare parts for repairing the robots had to be sourced from abroad. Musk acknowledged the mistake publicly. In a post on social media, he wrote, "Excessive automation at Tesla was a mistake. To be precise, my mistake. Humans are underrated." For a man who very rarely admits to miscalculations, this was a remarkable statement. But it was precisely this failure that became one of the most valuable lessons in the company's history. From that point on, Tesla restructured its entire manufacturing philosophy around a single principle: robots where they objectively outperform humans in heavy, repetitive, high-precision operations: welding, lifting body shells, transporting large assemblies, die casting. Humans where adaptability, dexterity, and real-time decision-making are required. This is Tesla's genuine competitive advantage: not design, not marketing, and not even battery range. The real battle in the automotive industry is being fought over the cost of production. The company that can build cars more cheaply than anyone else gains the greatest freedom in pricing, capturing market share, and funding the next technological leap. Tesla has demonstrated this strategy on numerous occasions, adjusting prices across different markets and placing pressure on competitors who simply cannot afford to do the same. If the unboxed process reaches its projected targets, the gap between Tesla and other manufacturers in terms of costs will widen further still, and then the question will no longer be who builds the best electric vehicle, but who can survive this race at all. If you're interested in how engineering decisions reshape entire industries, give this a like and subscribe to the channel. There are plenty more stories ahead about technologies that are rewriting the rules of the game.